Our last section in our unit will also be about frequency tables. However, in this section, we're going to talk about how we would calculate the more complicated probabilities of our intersections, unions, and conditional probabilities. Let's go ahead and start taking a look at the intersection probability. To calculate the probability of an intersection between two particular specific categories, for example, smartphone and iPod, we're going to go ahead and find the joint value which crosses between the two specific events that we're looking for. In this case, smartphone and iPod cross at the 20. So that's going to be our numerator. 20 out of the total 50. So 20 out of 50 is our probability, or reduces to 2/5. So intersection probabilities are fairly easy. Just find the joint value over the total. Unions are a bit more difficult. Unions will be the combination of all of the data values that fall within those categories. So if we want the union of smartphone or iPod, we actually want to add all of the joint values which fall in that category. So with smartphone, there are 2 joint values, and with iPod, there are 2 joint values. But as we calculate the union probabilities before, we want to make sure that we don't double count the 20. So that's why we're just going to go ahead and add the joint values. The 20 plus 18 plus 8. That'll get us the 46 in our numerator. And last but not least, we'll divide by the total once again. This is one way to calculate our union probabilities, by adding each of the joint values within the specific row and or column that you're looking for. So for our example, as I had mentioned, we did the 20 plus the 8 plus the 18 to get that number 46. Now, there's another way that you could get the numerator for a union, and that would be by using the totals of your 2 comparison quantities. So since we want smartphones or iPods, we could use our totals. The total for our smartphone is 38, and the total for our iPod is 28. So we could add those together. However, just like when we calculate the probability of a union, we have to make sure that we're not double counting the intersection, which in this case we would, the 20. So we need to take away the 20 so that we're not calculating it twice. If we do this, we will also get a 46. So you pick whatever way you feel is easier for you to understand, adding the joint values individually or adding the totals and taking away the intersection. Either way, you'll get your numerator value, in this case 46. And then your total should always be your denominator in a union. Last but not least, let's talk about conditional probabilities. Conditional probabilities, remember, are probabilities that you're trying to find of one event after you already know a second event has already occurred. When we have a two-way frequency table, we're essentially going to think about that second given event, and we're going to restrict our view to only that event to find the probability. So let's take a look at a couple examples. Here we have a probability that we want a smartphone, or that we have a smartphone, given that we already have an iPod. So this given information tells us what we already know. So instead of looking at the entire survey, we're only going to look at iPods. So we essentially restrict our view to only the iPods and ignore the rest of the table. Then we calculate the probability of a smartphone. Well, out of just the iPods, 20 people have smartphones out of the 28, and that would be our probability. Our conditional probability for no smartphones out of iPods, or given iPods, would again be just our restricted view of just the iPods, because that's the given information. 8 out of 28 people did not have a smartphone given that they had an iPod, so that's our probability. Now you could also restrict given a row. For example, let's find the probability of an iPod given that they don't have a smartphone. So in this case, I'm restricting my view to only the row for no smartphone. And I'm going to essentially block from my view all other rows, including the total. Now that I've restricted my view to only no smartphone, the given information, I can calculate the probability of an iPod. So an iPod has 8 out of the total, now 12. Probability of no iPod, given that they don't have a smartphone, is 4 out of 12. Okay, so let's go ahead and take a look at some examples, and hopefully you can catch on. So, just one quick reminder here at the top of the page. We can also determine independence by using the same independence formulas that we learned earlier. Our intersection probability formula and our conditional probability formula. So when we go to check independence, we want to use one of these equations to see if the two events are independent or not. Okay, so let's look at our problems. Part A, what is the probability that George Clooney was picked? So this is not an intersection, a union, or a conditional probability. It's a basic probability. So what is the probability that George Clooney was picked? So how many George Clooneys were there? 12 out of 51. I noticed that both of these are divisible by 3. 12 divided by 3 will give me 4. And 51 divided by 3 will give me 17. So 4 out of 17. Next, we want the probability that a 30-year-old was selected. Again, this is not a special probability. It's just like our basic probabilities we learned in our last section. So how many 30-year-olds are there? There are a total of 24, regardless of who they liked, out of 51. Simplifying, 24 divided by 3 gives me 8 out of 51 divided by 3, so that would be 17 again, so 8 out of 17. Now, the next two problems are going to be our intersection probabilities. Part C, what is the probability of being a 15-year-old and that they picked Christian Bale? So since this is an intersection, I want the intersection data value. So where does 15-year-old meet Christian Bale? 23. So 23 is our joint value associated with this intersection out of the total 51. And this is going to give our probability, 23 out of 51. D, what is the probability that, this is not correct the way it's worded. What is the probability of being a 30-year-old that picked Adam West? All right, so 30-year-old Adam West is 1, so that would be a 1 out of 51. Okay. E, given that a 15-year-old was selected, what is the probability that he picked George Clooney? So essentially what this is saying is, what is the probability of George Clooney given that they were 15? The given information is 15. That's going to tell me what I'm restricting my view to. So in my table, I'm only going to look at 15-year-olds. Now when I look at the 15-year-old row, now what's the probability that they pick George Clooney? Well, out of those 15-year-olds, 4 selected George Clooney out of a total of 27 15-year-olds. So my conditional probability will just be 4 out of 27. Notice that including the total, I'm restricting my view to the given information, in this case, 15. So that will give me my probability for E as 4 out of 27. F, given that Christian Bale was selected, what is the probability that it was a 30-year-old? So here we want to know the probability that they're 30, given that, so that's the second piece, they picked Christian Bale. So since I'm restricting my view to Christian Bale, I'm going to go ahead and erase my table and now just focus on Christian Bale, which would be this third column here. Restricting my view to the Christian Bale column, now I want to know what's the probability of a 30-year-old. There are 15 30-year-olds out of the 38 Christian Bale fans. So that would give me a 15 out of 38 as my probability. Okay, and that does not reduce. G, what is the probability of selecting George Clooney or Christian Bale? So here we have a union. So now I'm going to actually do the first one using the joint values, and then the next I'm going to use the totals just to see both examples. So doing this one with the joint values, what I want is all of the joint values associated with George Clooney and Christian Bale. So if I just look at George Clooney, the joint values associated with George Clooney are 4 and 8. And Christian Bale would be the joint values 23 and 15. There's no overlap here, so I don't have to worry about subtracting anything, nor would I need to subtract anything if I was just doing joint values. So I can just add all of these joint values up to get my numerator for this union. 4 plus 8 plus 23 plus 15. Okay. 4 plus 8 gives me 12. 12 plus 23 gives me 35, and 35 plus 15 gives me 50. So 50 is my numerator out of the total number of responses, 51. So that's a pretty high probability, 50 out of 51, that the person liked George Clooney or Christian Bale, which we can kind of see since Adam West only has 1 vote. All right. Let's take a look at H. What is the probability of being 15 years old or picking Christian Bale? So now I want 15 years old or Christian Bale. I'm going to focus on the totals this time. So 15's total is 27. And Christian Bale is 38. So I can add these two numbers together. However, when doing a union, you also need to remember that you might be double counting any intersection. And if we look, the intersection here would be the 23. So I'm actually double counting that 23 in both of those numbers. So in order to balance out the fact that I've double counted, I need to take away any intersection. This will get me the new numerator. 27 plus 38 is going to get me 65, and 65 minus 23 would get me 42 as my numerator. And this will be out of the total. Both of these numbers are divisible by 3. So dividing these by 3, let's see here. 3 goes into 42, looks like 14 times, and 3 goes into 15, 17 times. So my probability of a 15-year-old or someone who selected Christian Bale is 14 out of 17. So again, pretty high chances that I'm going to pick a 15-year-old or somebody that likes Christian Bale. Now, last but not least, is being 15 years old independent of choosing Christian Bale? In other words, would the age be independent of whether or not you liked Christian Bale? So you may have an opinion one way or another of whether you think this is true, but we're going to let the math do the talking. And we're going to prove whether these two events are independent or not by essentially proving one of the independent equations is either true or false. So we can either pick the intersection equation, the probability of A and B is equal to the probability of A times probability of B, or we can pick the conditional probability. The probability of A given B is equal to the probability of A. I personally think that the conditional probability is easier, so I'm going to use that one. So I'm going to show that this is or isn't true. So for 15 years old and Christian Bale, those are my events. So essentially I'm looking at the probability of a 15-year-old given Christian Bale. Is this the same as the probability of event A, in this case, a 15-year-old? Okay, so let's find the given probability. Given that they like Christian Bale, what's the probability that they're 15? And you know what? We didn't do that one. We did 30 years old. All All right, so let's go ahead and restrict our view to given that they like Christian Bale. So we're only looking at the Christian Bale column. And now, what's the probability that they are 15? So out of the Christian Bale folks, we have 23 out of 38. So that is our conditional probability, 23 out of 38. And we want to know, is this equivalent to the probability of a 15-year-old? And if we look at our table, it looks like there are 27 15-year-olds out of 51. Now, comparing fractions is a little bit difficult, so when I'm comparing, I like to go ahead and use the decimals. If I find the decimal equivalent of 23 out of 38, I get 0.60. And if I'm comparing the decimal for 2751, I get 0.53. As you can see, while these are close, they are not the same, so therefore these two events are not independent. If you were to use your intersection formula as well, you would also see that they are not independent. And that's it.